very good afternoon. Can I get back? Sonnadan. A very good afternoon. Good afternoon. Good afternoon. La nimathu parunga. In the last session of our session, and I love to listen to this clap because you're all young blood, right? You want to rock always. So for the session of Sridevi ma'am, Dean Humanities and Sciences, to chair this session, and we also have Dr. T. Reddy ma'am, who is additional Dean of Engineering Technology as the co-chair. We welcome you, ma'am.
So good afternoon, everyone. Hearty welcome to all the guests assembled here, and also our respected Rector Dr. D. Vishwanathan, Additional Registrar Dr. Silra sir, and the members of the Dr.M.G.R. ACS Space Technology Center. And also I welcome the participants who are assembled here. Please maintain silence. So I welcome Shri Vikram Sivaprakashan on the topic, going to present the presentation on the topic Satellite Internet Systems, Need and Applications of Satellite Internet. Satellite Internet Systems plays a vital role in serving remote and unserved communities with LEO constellations such as Starlink providing fiber-like low latency and global coverage. Phased array antennas and beam steering in new user terminals provide a high throughput and mobility. So applications include rural 4G, 5G, backhaul aviation, maritime, and disaster relief. The transition from GEO to LEO and MEO orbits lowered latency, enabled inter-satellite laser links, and improved onboard processing, improved preparations, adaptive modulation, and generative payloads, improve efficiency and resilience. With the advancement of this laser and THZ technologies, satellite internet is becoming a resilient and high-speed global network. So, in the topic Satellite Internet Systems, I welcome Shri Vikram Sivaprakashan to present the presentation.
Good afternoon to all of you. So today it is a great day, and I really appreciate our Rector sir and Dr. Cyril sir and our ACS SAT team for this predominant very good area of satellite seminar. And it gives me immense pleasure to introduce Mr. Vikram Sivaprakashan, who is an accomplished technology professional with over 14 years of experience in software development, embedded systems, DevOps, and engineering management. His career spans over a wide range of industries like automotive, industrial automation, mining, SATCOM, and his adaptability in applying technology across various complex domains. He's at present working in KPIT Technologies, Chennai, and he's also a subject matter expert in embedded systems, industrial automation networks, and DevOps. Vikram's technical strengths lie in embedded hardware, board bring-up, firmware, middleware development, application layer integration, and user interface design. He has a very deep experience in the design and implementation of industrial communication protocols, security frameworks, particularly related to the industrial automation environments. So we are really great to have such an eminent young personality here who can share his views and his accomplishments with us. So I welcome you, sir. Please.
Good afternoon, guys. Okay, I know post-lunch session is the hardest. It'll be difficult for you to listen and keep your eyes open. I'll try to make it as short as possible. Okay, thank you for the warm introduction, ma'am. And as ma'am said, I have been working in the industry for 14 years. My base is from EC, but I chose embedded systems as my primary core working area. So one advantage of getting into embedded systems, you get to work across multiple industries, because anywhere you have hardware and software together, you have embedded systems and you get to work on it. And because of that, you get to know about each product and how it works in the field. I am not from a research background, so I represent the private sector, which basically uses satellite technology for commercial applications development. So yes, I think our ISRO and even Vikram Sarabhai had said that Indian space research is mainly for the public service of the common man. So one of the most common usage for a common man is today's internet. And so I wanted to give you an overview about satellite internet as such. So satellite internet has been there for around 25 years. I think a lot of people would have already known about Starlink, that is led by Elon Musk. So that is, I would say he's one of the most recent entrant. But even before Starlink, around for 15 years, we have been having satellite internet. The most important thing, the satellite telephone is a completely different technology. Satellite internet is a different technology. So here we're focusing on the internet side, not on the telephony side. Why do we need satellite internet? Because we have 5G, and soon we are going to get 6G. We have Broadcom, we have fiber optic communications. That gives you a very high latency, very high bandwidth locally. Still, SATCOM is essential. Why? Because there are a lot of places where your traditional broadband networks cannot access. Rural areas, mountains, hilly terrains, and most importantly, on the maritime industry, where if the ship goes beyond 12 kilometers range, you cannot use any of your normal communication devices. So at that point, you need to use satellite communication again. Maritime, shipping, and aviation. Today we are very much connected. Even when we are going in aeroplane, we expect internet connectivity to be available. And for that, you need satellite communication again. And most of our work, including the personal data, is now residing in cloud. I'm quite sure a lot of people are using Google Cloud, Amazon's cloud is there, you have Azure, and even you have OneDrive. So all these cloud technologies are storing data somewhere in the internet. And those data centers are supposed to be operational 24/7. You just can't have basic systems. You need to have backup of a backup of a backup. They are called as redundant systems. So for those redundant systems, SATCOM is one of the chief provider of redundancies. And yes, for emergency situations, disaster response, and for all those areas where your traditional mobile towers will not work, satellite internet is very important. Okay, so I was working for a company called Viasat. You might not have heard of Viasat before, mainly because in India, internet is not being provided through satellite communication. It's only through your traditional broadband and mobile. So this company has a lot of contracts with defense, especially in the US defense. I think you know of Air Force One, right? Anybody knows Air Force One? That's the US President's plane. So Viasat provides internet support for those planes. So whenever those planes fly in the air, they are expected to be connected to the internet at any point of time, because they are carrying leaders who has impact on the world. So for that, we provide the internet services, defense services. If you have looking into lidars and unmanned aerial vehicles, UAVs, all those are connected through internet, and all those internet services for the US defense and the government is being provided by Viasat. So this company has been there for 25 years, but you won't have heard a lot of it because they are primarily a business-to-business solution. Until now, this internet is actually used by other businesses. It was never commercially available until for the last 10 to 15 years. So with respect to satellite communication, you have two different technologies, depending upon which area you're going to have the satellites in. One is the LEO, and other is the GEO. GEO is a geosynchronous orbit, obviously, and that is the traditional satellite technology that is used for internet. LEO is more recent, and the only operational satellite internet in the LEO orbit is Starlink. Maybe we can get more detail into Starlink at a later point of time. Just wanted to give you an overview. So because of the distance at which these satellites are, they use a radically different technologies. You cannot use the same technology that you use for GEO to contact to LEO also. mic.
Hello, Chick.
Mic. Okay. Why do I wanted to show here this? How a typical internet works. So you know how everybody has a modem in your home. It is connected to the broadband network, and you get the internet through that. In satellite, it is pretty much like a dish TV. The only primary difference is that your modem is called a user terminal, and that user terminal is capable of having a two-way communication with the satellite. Usually, a dish TV's set-top box will have only one-way communication. It cannot transmit, it can only receive. So you have something called as a user terminal, which will be in your home, and it will be connected to the dish antenna, through which you will be communicating to the satellite. So this is the basic operational model. Okay, with respect to LEO, the latency is the amount of time it takes for your packets to be sent and received. That will be very low. And because the latency is low, you will have a higher throughput. People who do gaming, they can understand about latency. When you're doing online gaming like PUBG and all, if you have to have a very fast internet, because whenever you press any button, it should be acting immediately, because it's a server. So for that, a low latency network is highly preferred. That's why you see a very good difference when you play in mobile versus when you play in your home Wi-Fi. Similarly, for LEO, the latency is very, very high. The latency is low and the throughput is very high. So as I mentioned earlier, Starlink is the only commercial provider that is working in the LEO orbit. Geo is a traditional provider. So my company is a geosynchronous satellite provider only. So what we do is, it's pretty much the same thing. The only difference is that we have to have the entire internet infrastructure created for ourselves. So we'll have a satellite which will be at a geosynchronous orbit, that is 36,000 kilometers above. The same user terminal, everything will be the same only. The only difference is, here the latency will be very high. And maybe we can get to the antenna later. Because the latency is very high, you will have a good internet, but you will not have a very responsive internet, in a sense that when you press a button in gaming, the reaction time in the server will be low, because it has to travel through around 72,000 kilometers, because it has to go up to the satellite for 36,000, and then have to come back again for another 36,000. So that is going to take some time. So HugeNet is another provider. Viasat, we have Intelsat, and there is something called as Inmarsat. These are the common providers which work on the geosynchronous orbit. So basic difference between how LEO and GEO works. I'm not going to get too much technical into it, but you can go for a quick reason. So with respect to LEO, I'm using something called as a mesh or multi-hop structure. Why? Because you cannot provide internet with a single LEO satellite. You need to have hundreds and thousands of satellites to provide internet. Right now, Starlink has around 5,000 satellites online, and they are planning to increase it to 12,000. Only if you have around minimum of 10,000, you can provide enough amount of coverage for the entire area. So when you're going to have that many number of satellites, you can only use a mesh architecture. Why? Because whatever signals you send gets bumped from one satellite to another, and then gets back to the ground, because these satellites are not fixed. Since you would have definitely known about LEO and GEO. LEO orbit satellites keep rotating around the Earth at a much, much faster speed compared to GEO, which means it will keep moving around the Earth at a faster rate. GEO satellites, on the other hand, will be fixed in a single point on Earth. So GEO will not move with reference to Earth, but LEO will keep rotating at a faster rate. So we need to send a signal to a LEO satellite at now. By the time it gets it, it will be in a different place. And by the time it gives it back, it will be in a totally different place, because they travel around 27,000 kilometers an hour. So obviously, LEO, if you're going to use a single satellite, you cannot provide internet. So that's where we need to have a mesh architecture. We can get more into details later point. GEO is more straightforward. Since it's located at a very strong, smart, common reference point, you just need one satellite. You know the satellite is always going to be there only at any point of time. So all you have to do is make sure your dish is pointing to that satellite. Automatically, the dish will transfer the data to the GEO, and you'll get it back. So that's much more easy and simpler architecture as such. And with respect to ground stations, GEO satellites, you need to have a full-fledged ground stations. We have around 4 data centers across the world, in Australia, in Ireland, in Brazil, and in America. So these data centers are complete data centers, around acres of size, just to communicate with these geosynchronous satellites. On the other hand, Leo, since it's closer, you can have very, very small data centers. Just like a very small dish, proper dish with a small data center will be enough for you to handle a Leo satellite. And another key difference is, in Leo, you don't have satellite-to-satellite communication at all. You transmit the data to the satellite, it receives, and then it comes back to the ground. In Leo, because the Leo satellites are going at a very, very fast rate, you need to have an inter-satellite link. What it does, whatever data you send to the satellite sends to the rest of the data, rest of the satellites. Why? Because now, as I mentioned earlier, let's say I'm in Chennai, I'm sending a data to one Leo satellite. At that point, the satellite will be on top of Chennai. By the time it receives the data, it will have crossed to Andaman. So now, it has to relay the data back to me in Chennai. So it cannot relay because it has gone beyond the Chennai range. What it will do, it will forward this data to the satellite, which is at Chennai now. And that satellite will take it through the ISL link and then give it to me, who is in Chennai. So that's why you need to have ISLs for Leo orbits. Beamforming and spot beams, this is more on the antenna side. I'm quite sure people are from AC background. So why you need beamforming is because you need to focus certain areas where a population is very high. If, like I said, let's say the same example. Chennai has a high population. Compared if you go to a more remote district, it's outside, like Ramanathapuram or some place like that. The amount of people who are going to use internet there will be less from a satellite perspective. So what I will do, I will try to focus more beams in Chennai and reduce my beams in Ramnad. So that is possible in Geo. But in Leo, that's not possible because the beam itself is very, very narrow already. So you cannot do any minimization of the beams further. And the biggest difference is the antenna. A Geo antenna, you can just use a very normal antenna. A normal dish TV antenna like you use for the sun dish TV, that's more than enough for a geosynchronous communication. Leo, on the other hand, you cannot use that antenna. Actually, in Leo satellite systems, Leo antenna is the most sophisticated form of antenna because it should be capable of knowing which satellite is there at which point of time in space. Only then it can actually make the communication. Okay, I'm definitely not going to go through this, you get bored. Okay, this maybe we'll get to do it when we get into Starlink. Okay, so just wanted to share something about Viasat. So we have been in the industry for 30 years now. So we use basically 5 to 6 satellites altogether to provide internet connectivity. And we are able to do that because, as you can see, when you're going to geosynchronous, you need only 3 satellites. Why? Because each satellite can cover 1/3 of the Earth, which means with just 3 satellites, I'll be able to provide internet for the entire world. The only problem is I can provide a high bandwidth, but I cannot provide a high, low latency network here. So how? One minute. Audio. 1 minute. Just a minute, guys. The audio needs to play. So what we felt was, obviously, Starlink has come into the market, and Starlink is taking most of the bandwidth. So what we thought, we cannot compete with Starlink. Why? Because Starlink is owned by SpaceX. SpaceX can launch as many satellites as possible, so we cannot compete with them. We thought we will still stick to the same geo orbit. We will have 3 satellites. We will try to provide what Starlink cannot provide. We will try to provide 1 Tbps internet. 1 Tbps internet is never achieved in satellite technology until now. So we thought we will do that. So what we did was, we thought we will go for the new range of satellite called Viasat 3. We'll be launching 3 satellites altogether to geosynchronous. The difference is the antenna. This antenna is a very, very innovative antenna approach which was developed in-house by us. And we actually partnered with Boeing for developing that antenna. So this is just a promotion of that particular antenna. maybe it's loading now. You can see that what we did was we developed an antenna which will open up in the space. So you can see the satellite is here. You have a huge parabolic antenna created. So this antenna was developed in-house. What we want to do was, it will be like an umbrella model. We just went with a typical umbrella model. We will fold the entire antenna and put it inside the rocket, because you cannot ship that particular antenna as it is. You cannot deploy that as satellite. So we folded it like an umbrella. We tested a lot. We tried to see a deployment mechanism by which we will be able to achieve 25 square meters of surface area. That is enough to give 1 terabyte of speed. So what happened? Everything went as planned. But when we launched the satellite, the antenna did not open up. So instead of opening up completely, it was only opened partially. So we wanted to get 1 terabyte of speed, but we ended up getting only 150 Gbps. So it was basically something of a failure for us. And that was because, as we will receive a lot of presentations about how difficult it is to develop something on the space technology side. Especially Kalpana was talking about qualification 1, qualification 2. No matter how many times you test, sometimes in the field it will fail. So this is a big fail for us. We invested almost around $200 million on this one. And because that particular deployment mechanism did not work, we were not able to get the complete bandwidth from it. So we have stopped the launches of the remaining 2 satellites. We are still trying to figure out a different way of launching them and deploying this particular antenna. So the main idea for going for this particular antenna was to compete with SpaceX. You cannot compete with the LEO satellite orbit on the latency, but you can compete with them on the bandwidth side. Okay, any questions so far, guys? Yeah, please. Yeah. It works on the LEO side. See, as I mentioned, they are still on development stage. You also have Juniper, that is another joint venture that has been happening. That is a LEO satellite as well. But nobody has an operational internet except for Starlink and LEO. They are still trying. See, the main problem is, if you want to have a LEO satellite orbit, you need to have at least 5,000 satellites. And you need to have a capability to launch 5,000 satellites. The reason Starlink is successful because it's owned by SpaceX. They have their own rockets. They can launch how many ever satellites they want. If somebody else, like a third party, wants to create a LEO satellite orbit, they have to pay to get the satellites launched. So Google has the money, but it still needs to work on the other items. Amazon is also trying to do the same thing, but their satellites are not yet operational. They have trying it, but they still have a lot of logistical challenges, which Starlink has already solved. A balloon sort of a thing. Okay, yeah, you can work with the balloon, but how will you service it? Like, what is the height at which you're looking at? How many balloons can you launch? So from an operational perspective, it makes sense if you have a localized communication, that will work. But if you want to cover a big area, like let's say, if you want to cover Chennai, think of what will be the surface area of a balloon. Let's say it can cover 1 square kilometer of area. Then you need to launch at least around 150,000 balloons just to cover Chennai area, because Chennai is around 150,000 kilometers. I'm giving you an example. So it's always about practicality and feasibility, because we are here to make money. In a private sector, it's about making profit. If I cannot make a profitable venture out of it, I'm not going to give it a try. Even when we went for that 3 satellite system, the reason we went for that was because only 3 satellites. If I build it and launch it, it will be there in the sky for 30 years. I don't have to worry about investing or doing anything. Build, launch, forget. That's possible. But if I'm going to have these balloons, right, I need to find a way to service. Starlink has those problems now, because Starlink satellites has an age of only 5 years. After 5 years, it has to get automatically deorbited. They still have struggling with space debris. They're having a lot of other problems. But the basic technology they have solved. We'll focus less frequencies on remaining areas. So we have different get-up also. In Brazil, for example, we have Amazon forest in Brazil. So there are a lot of communities inside Amazon forest who don't have access to internet, because it is banned by law to actually provide fiber optic communication to the forest. So what we did was, instead of actually going for that, we went to something called as community network. So there we'll have one strong Wi-Fi point, which will actually talk to our satellite, and that satellite, through that Wi-Fi point, now a community of around 500, 600 houses will connect to it. It's like having one big Wi-Fi network. So that is possible. So that is also possible because of the beamforming areas. So as I mentioned earlier, so geo satellites uses spot beams. We try to cover entire Earth with using specific frequency bands, and that frequency bands will be mapped to the area. So we know for sure that frequency band will be used there only because we control the antenna in the geosynchronous satellite. Okay, other things I think you have to write down. Okay, as I mentioned, between the beam size, okay. So when you look at geosynchronous, as I mentioned, the beam size is going to be much, much bigger compared to LEO. And the coverage flexibility in geo is higher. LEO, you need to have more beam shifts. But comparatively, the configuration will be more simpler on the geo side. Okay, this is basically a rehash of what I showed a bit earlier. Okay. Any questions on how the satellite internet works, about beamforming, anything like that? Third. Okay. Since it's the latest technology, I wanted to cover this specifically on Starlink. Okay. So as I mentioned, it is working on LEO orbit, and there are about 5,000 operational satellites right now in Starlink network. And right now, they are providing very low latency networks, which means why latency is very important, because let's say you're in a financial market, you're in stock market, for example. If you're going to buy a stock or sell a stock, even a millisecond makes a difference. And that millisecond difference will make a huge difference for you from a profitable point of view. If you are going to have a fiber optical fiber network, it will be very fast. And if you're going to have a LEO satellite, it will be fast. If you're going to go for GEO, and if you're going to try to place an order, automatically take a lot of time. So you might lose out on the order. That's why you need to have a high latency networks, so which ensures that you are able to communicate at a faster pace. Okay. So the basic architecture is always going to be same. You are going to have a user terminal, you are going to have a satellite dish, you are going to have a satellite, and you are going to have a ground station. So the biggest difference in Starlink, for that matter, what made it possible was not the satellite, because satellite is very easy to create. They are not using any breakthrough technology in satellites. The biggest innovation from Starlink was the dish. The dish that you are using, Starlink dish, that is something called as a phased array dish. It is individually powered, and these antennas have the smartness to find out where the closest LEO satellite is available. And it can electrically get steered to that particular LEO satellite and get the beams from there. That is the key success for Starlink. And another reason, this particular dish antenna is very, very costly. It's around, they have not revealed the production cost, but based on industry estimates, we estimated that a single phase dish antenna that you're using costs around $700. $700 in our measures almost 1 lakh rupees. So for each and every antenna they're using in the customer, like you or me, like a Sun Dish TV antenna, that one antenna is 1 lakh rupees for them. If you're going to price 1 lakh rupees for one antenna, nobody is going to buy your internet. What they've done, they have went for a lease model, wherein you have to pay a monthly rent and get the antenna. But this antenna is the key difference. So as I mentioned earlier, so it's going to be operating at a very high speed. Okay, so what happens is, every time when you want to connect to the internet, the dish finds the the nearest satellite to you, connects to that satellite, and transfers the data. That satellite has entire satellite network, which means it can communicate with all the 5,000 satellites as and when required. It will just ping your data to other satellites until it finds the right space, gets the data, and brings it back. As I mentioned, this is the key component for them, the user dish, that is actually able to get your internet connection correctly available for download and upload. Another one problem with Starlink is that this antenna requires clear view. Even if it's very cloudy, it may not work. If it's going to be rainy, it may not work. Comparatively, Geo has a much more resilient framework with respect to this. Ground stations, we already covered. It's not going to take much of effort for setting up the ground station because it'll be much more easy for them to set it up. It's a very small network only. And as I mentioned, internet satellite links. So these are done through optical sensors and optical fibers, which ensures that the data gets transmitted between the satellites, not just between the satellite and the ground station, but also to the satellites also. So this is a typical operation. So you send a request to the passing satellite. The satellite relays the data to the nearest ground station, and then the ground station has its own internet facility, gets the data and gives it back. When you have OASL, the same thing happens. The only difference is that the satellite will forward the request to another satellite. It will keep pinging across multiple satellites, and then eventually it will find a good ground station which is close enough, and then it will get the data from that. So because of this, Starlink is achieving a latency of 20 to 50 milliseconds. But if you look at geosynchronous, it takes 600 milliseconds. And the download speed is also, if you look at download upload speed, more or less it will be the same only. Because once you establish a connection, the bandwidth is going to be the same. It's only about the speed at which you are establishing the connection is going to be different. And because it's a LEO, and because of the nature of the antenna, LEO has high temperament towards weather. For inclement weather, LEO satellites will not work as expected. GEO is much better compared to that. Okay, and this is a common problem. Like Kalpana ma'am said, space debris. Because there are a lot of satellites, a lot of space debris is happening, and that needs to be managed better. And more importantly, the frequencies we are using, there is a lot of congestion in the frequencies. That has to also be taken care of. Okay, that's pretty much it. That's pretty much it from my side, guys. I have another slide, but I don't want to bore you. Any questions?
Questions, please.
Okay, fine. You need to be very strong on the coding side, obviously. Why? Because most of the work we are doing is on the data center side. Because we launched satellite only once for 20 years. So that is going to be taken care of by people holding PhDs. You should be good on the network stack development. You need to know about TCP/IP models. That was actually another slide, but I don't want you to bore the class because there is something called as performance enhancement proxies. You need to know about that. You know about TCP/IP, right? OSL, nothing.
Yeah.
Okay. So you have something called as performance enhancement proxies, which are specifically designed for satellite internet. You can go through the RFCs also if you require. I can share the information offline to the staff. We can have a look into it. You need to have a very good idea about network stacks. If you can, network means about data link layer, about transport layer, about physical layer, how it works. If you can have a very deep understanding of it, it's easy to get into the network communications company, not a problem. It's very much similar to Cisco or Nokia. Nokia is actually into 5G now. It's very much similar to that. Only thing is the stack will keep differing. You'll be working on the stack mostly. The antenna will be designed by. Okay, thank you guys. Yeah, please, yeah. Sorry, just one more question. I'm very sorry. We can clap after that. See, every frequency that you have in the radio frequency, they have a name. KU band is one name. KA band is another name. This KU and KA band is used more often for satellite communication. Okay, it's in gigahertz range only. The problem is it's used for a lot of satellite communication, even for internet, for remote sensing, and for images, whatever you want to do, communications for the TV broadcast. Also, it's being used. Same brand is used because the same band is used for a lot of work. There is a lot of congestion happening. Like you have Wi-Fi, right? Wi-Fi uses public frequency, 2.5 gigahertz. Everything, even Bluetooth, Wi-Fi, everything uses 2.5 gigahertz. So a lot of interference is happening. The same interference is also happening for internet as well. Those basically represent the frequency bands that are used for internet providing. Okay. Yeah. Yeah, it will definitely be a problem in the future because the amount of space debris we have is high. So there are two approaches to it. One approach is that a technical approach where they are clearing the space debris itself. We have something called as the electromagnetic net. What it is that it's like a, look at it like a fish net. Okay, it can actually electromagnetically attract the debris and collect it and deorbit so that you would not have a space debris issue. Another thing they are trying to do is they are mandating requirements to every satellite to safely deorbit. Space Starlink is the first guy who is actually doing it. Now they have something called as ion thruster engines. So that's basically responsible for steering the satellite even after launch. See, once you launch a satellite, you don't steer them. It just remains there. But now these guys have a steering point safe. The idea is that 5 years down the line, when they want to deorbit that particular item, they'll use these engines to ensure that it actually comes to the ground. It is not left as debris in the space. So now the FAA, Federal Aviation Authority, International Aviation or Administration, they're all saying that whatever you launch into the space must be deorbited without getting broken up. So that is a responsibility of the person or the industry or the company which is sending the satellite. So that one is avoidance. The other one is still in the theoretical stage only, where I'm talking about electromagnetic shield net that will attract that debris. It's still in theoretical phase. It's not practical yet. But yes, if we keep the current rate, this will definitely be a problem in the future. Okay. Now you can clap, guys. Thank you.
Thank you, Vikram. Thank you, Vikram, for giving enormous knowledge about satellite internet systems and differences in LEO and GEO technologies, pros and cons and challenges and limitations. So we got a very good knowledge about the thing. And I think some of our students may try to work in this domain also. Thank you.
Thank you so much, sir. It's now time to honor our guest speaker, Sri Vikram Sivaprakashan, subject matter expert, APIT.
The next speaker, Mr. Kishore Ashok, on the title Empowering Women in Space Technology, Director and CTO in Aero and Space Tech Private Limited. Welcome you, sir. So on the topic Empowering Women, Space Technology is transforming science and global collaborations, yet gender inclusivity still lacks. Kishore Ashok highlights the urgent need to empower women in the space sector. Drawing from his work in sustainable launches and space debris control, he shares key insights. The session explores barriers women faces and the innovation in their inclusion can unlock it. It also offers the practical steps such as mentorship, inclusive hiring, and equitable education access. Real stories of women in aerospace showcases the progress and promises. Kishore is going to emphasize the value of diverse, cross-disciplinary teams and the future of space. He argues must be inclusive and collaborative. Let us start, Ashok sir.
So, is it audible?
Yeah. It gives me immense pleasure. Okay. It gives immense pleasure to introduce Mr. Kishore Ashok, who is a director and chief technological officer of Aero and Space. He worked as a senior scientist and research cosmonaut at Canadian Space Agency. And he's a director and CTO of the Aero and Space, who has 7 years of expertise in aerospace engineering, robotics, satellite technology, and sustainable propulsion. He is also actively involved in various international space missions, nano-satellite launches, and he has patents in the area of advanced space technology. He developed robotic process automation tools to streamline mission control workflows and satellite operations, which supports Canadian growth presence in the space. And he's in collaboration with the NASA as a citizen scientist. He contributed to the Earth science and propulsion research, leading projects in the electrical soil propulsion systems, e-soil technologies, and various other successful launch of the satellites. He holds a MSc in Fluid Sector Interaction from McGill University, Canada, and BE in Aeronautical Engineering from VTU, Bangalore. And his technical skills are CAD/CAM design, mission planning software, green propulsion systems, and space debris mitigation, which is a very important area in space technology. So we are very happy to have in MGR University to share his views. Thank you, sir.
It's on, right? Yeah. Good morning, everyone. It's myself, Kishore. And as ma'am said, engineer who's working for Indian Space Agency as a RPS scientist, as well, right now associated with Aero and Space Tech as CTO and director as well. So it's been more than 6 years, I guess, in the same industry with the same, what I'll say, sustainable rocket launching technique and space debris techniques. So apart from this, I just want this session, before sessions maybe as a seminar or like what I'll say, a technical stuff, but as the insights I got from my teammates, it's just a guest talk, they said. Since then, I didn't prepare any sort of slides or something to just visualize you guys. But I make sure that this session won't be like, what I'll say, doubtful or boring one. So let's start with a simple note that as how the balance is required for the rocket science, it is important for gender equality in the same, what I'll say, space science to get involved in the aerospace industry. And guys from last, am I audible or what? Is it fine, right? I wish you guys want to be interactive, so make sure that you are getting the insight from your side as well. So as far as we know, like we may heard of a lot of women names in the industry of space, like started from Valentina to Kalpana. We never know what actually they did. It's all about exploring the space, or like those who gone to space, we may know about their names. Apart from that, we never know anyone's. It's always underrated as well. It's always, what I'll say, underestimated in that particular term. Well, in terms of my experience, I started working for CSA from 2021, okay? I seen a girl called Annie who came as a project intern, and right now she is the one who gonna lead the Canadian Space Agency's second astronaut in the mission called SLS Artemis 2, okay? Have you heard about a mission called Artemis 2? So it is a mission after 60 years from NASA who gonna reach the moon with the humans again for a long period of time to take proper to get a proper information about the moon, which we never know about, which we never get to learn about from the satellites or so on. Okay, it's a particular mission which is concentrated equal preference to the female as of male. So there are 7 astronauts. Among those 7 astronauts, 3 are from female background and 2 are from Canadian Space Agency. One's name is G.R, who is my senior, and one's name is Annie, which I said she's a junior for me as well. So what I mean to say is, the space industry, it's not just only for the humans who, it's not only for the men who is enthusiastically about rocket science or cancers or whatever it may be. It's all for everyone who are having the basic interest on what is space as it is, okay? Instead of blabbering something, instead of just pouring the experience or instead of just saying what I know, it's better if we talk or discuss about the project which we are working in Aero and Space Tech and the project which I am leading right now, I guess. So this is a project which is named SBRL, which is Stratospheric Balloon Rocket Launcher, where as your colleague asked, what I'll say? What if we are continuously putting the debris on the space, how it will affect in our future missions. As we all know, prevention is better than cure. It's a rocket launching technique which is non-conventional, firstly. We are not gonna reach the common space through the extra boosters which we having, or extra, propellants which we will use in regular conventional rockets. Instead, we'll just bypass that medium with the balloons. From the area of Kármán, we'll just start the igniters, and then we'll reach the desired space or areas. It's all about how, I mean, we may have a lot of doubts in it. Like, let me just go by. On the region of Kármán, we are just igniting it, right? So from that particular region, we will just first cut the economical crisis. In a rocket launch, around 60 to 70% of the whole propellant, whole budget will be utilized only for the propellants. Whereas in our proposal technique, we will just reduce that 60% first, so it's cost effective. And there is no liquid propellant or any any sort of hybrid propellant. So what it happens is the movable part will be automatically cut down, so the debris will be reduced over here. And the only movable parts are the fairings, which is systematically a nose cone, which will be heading to the outer space out of ablative materials. And the payloads will be the only ratio, which, the payloads will have the more weight ratio compared to the propellants or the whole rocket structure. By this way, we can, again, firstly, cut down the cost. Secondly, we can cut down the debris thing. Third thing is it's more sustainable compared to others. Like as we consider the inner or atmospheric environmental stuffs, if we are launching in this manner, we'll just get the things done in better and easier way. So this is how, this is what the thing is happening in Aero Space Tech as of now. And this is a project which we are, which I wish to just share with you guys, and you may get a lot of insightful thoughts from others and not from me. It's just because of the miscalculation and misunderstanding which happened. Personally, me doesn't know that it's a seminar, first of all, okay? I just get to know that it's a guest talk for students, and that too I just got to know yesterday, sir, so sorry for that. And if you have any doubts regarding, any sort of space industry oriented doubts, just ping me out, inquire me out. I'll try to solve it out. And as the topic is from empowering the women, how many of you know about ISU, International Space University? Anyone? People are from different disciplinaries, right? So there's a university called International Space University located in France. For female cadets, particularly for female cadets, those are the guys who are giving a scholarship called Kalpana Chawla Scholarship Scheme, which if you are, guys are grading enough to crack the, bar lines, you'll get around 70 to 90% of the whole scholarship, which means if you want to do your masters in the space related stuff, if you are applying directly for it, it costs you around in 6 digits, I guess, if I'm not wrong. While if you wish to do it, people are there for as a national point of contact who can give their LORs to you, so that you directly can apply from their LORs and you'll get around 70 to 90%, I guess. So make use of it. Don't just hesitate for anything. As in my own experience, it's not about how you are and who you are. It's all about the idea which matters, okay? No one knows where you come from and no one knows who you are. It's all about the particular idea. One brilliant idea and one revolutionary object or a prototype can change your whole life. It happened in my own life, and I'm suggesting the same thing to you as well. It's all about the proposal which you read. How many of you are having a habit of reading journals or writing technical papers? Oh, I didn't know that as well, sir. So at first year, you start to learn about these things. Try to read journals, okay? Reading, not knowing things will let you know having a discussion with fellowships, okay? That discussion will encounter you to have a debate with them. That debate will get you a lot of confusion. That confusion will get you a lot of innovational ideas. That innovational ideas will keep you in a place where you are wishing for. So try having the same habit of doing this again and again. And I guess you guys are gifted with a lot of dignitaries over here in the college itself. Make use of them. Don't be hesitate for anything. Okay. Anything from your side, like any sort of doubts or something? Anything related to your own career or orientations? Nothing such. Regarding from your side, you are asking a lot of space debris thing, right? Yeah. See, actual thing is people are trying to capture it. It doesn't mean that they will go and plug the trash heads. It's all mean that, see, let's take an example of Hubble telescope, okay? Do you think it's, what else? It's actually a debris. It's still working. After years, it will go as a debris. But the components won't be a debris again. So it's still useful stuff. We can just regain it to the ISS where we can rework on it and relaunch it. It's all in that manner. We are not trying to capture everything. As well, there is a thing that called, away from LEO GEO, there's a space called graveyard space. People used to call it as graveyard space. Why? Because as Sir said, as Vikram said, there is ionic thrusters which is steering the satellites, right? After a certain period of workment, they'll try to put that in that particular area so that it won't affect the actual orbits. It's again a simple solution for avoiding the debris, but in practicalization, there are still a lot of proposals which are working on. There is something called robotic arm. Have you heard about it? People try to figure out a space where we want to launch. We just want to clear that particular space. Obviously, there will be a debris away. But as of the region, we are trying to clean that region in the sense, we will, if we are in need of the particular coordinates, we will try to figure out that particular place. We'll do an algorithm on it. We'll just find out how many debris are over there. We'll try to launch a robotic arm over there. That spacecraft will plug it out. It's a, it's a prototype which is building by ESA, European Space Agency. Those are the guys who are working a lot on space debris particularly. And there is, while speaking on debris, there are a lot of debris. Apart from artificial debris, there are a lot of natural debris as well. Let's say asteroids. How those are all getting distracted? There are some plants, right? DRAT mission. What, have you heard about DRAT? Either they will just put an explosive and burst it out, or else there is some other plan. Like we'll try to steer a rocket launch near to that, so that particular natural debris asteroid is there. No, it will just deflect its own orbital path. So it gets deflected and it goes somewhere. So these are all the current technologies which is which is using for avoiding the debris. It's not about avoiding the debris. It's all about preventing from debris. So we didn't have any such exact proposals. Even I had a patent which got me a job in CAC is a project called STAR, Space Trash Accumulator and Recenter. So as he mentioned that the electrostatic net, right, we just use the solar sails in graphene material, which we just observe the solar energy in terms of proton, and so that the umbrella will open up, and once it's getting shrinked off, we'll put a lot of force into it, right? So that the debris will come off and they get into the spacecraft. If it is needed, we can get into the Earth orbits. That is how it works. Anything else?
Sir,
Yeah.
so the program which you have launched, that stratospheric
Ma'am,
balloon
it's
rocket.
not launched yet. The prototype has been done,
Okay.
and we do have the mission analysis test and all. We are on a pace
No,
of
even
launch.
the model, what I mean to say is, I think the initial thrusting may not be sufficient for the
To
rocket
get
launch.
away from
Yeah,
the escape velocity, right? The
absolutely.
propellant which we are using is our own patented propellant, which is capable enough of making the thrust in 3 to 6 seconds.
Okay.
This is how that, theoretical calculation worked on, ma'am, as of now. We are yet on a process called static testing on a lot of things. We will do our static test in India by this coming week in Karaikal,
So
which
yours
is
is a startup company. Where it is located?
it's located in Chennai, ma'am. Mine is, to be frank, I'm working as a Canadian, RPS scientist in Canadian Space Agency even now. On and off, I'll just be here in this Aero and Space Tech for a project.
It's available in IT Research Park? Huh?
No, ma'am. It's yet in Medavakam.
Okay. Fine.
We are yet to incubate with IITM, but there are some difficulties which is happening around. People are asking us to share with rights and all. It's a patented technology on my name, which I patented on 2022, I guess.
Oh,
so right now I'm trying to add inventors in this particular patent. Even that is not getting approved right away. So it's an individual patent as of now. We are trying to make it out, and by coming Wednesday we do have our first static test.
Okay.
Once done, by the end of May, we will be having our second text in Roxel, France, ma'am.
Okay. Thank you.
Thank you. Actually, we do have a cell where we have tried something. Let me say that as well. Actually, we do before then it was a paid internship, I guess. I mean, paying internship. After I got associated with this, we are trying to scaling up the team. Okay. Instead of hiring people, we are hiring interns, sir. Internship of long 6 months, so that we will give stipend to them. We'll just get the work from them. We'll give credits as well to them. We are doing the sharing things as of now. We do have around 220 applicants from Amrita, sir, which we filtered and took around 8 cadets from Amrita University last month. So as I know, there is a MOU between Aeroin and MGR. We are coming with a proposal to MGR as soon as possible, sir. We'll be coming and we'll be picking up.
Yeah, thank you so much, Ashok. Our best wishes for your newly startup company. Soon it will become a global network. Yeah.
Thank you so much, sir. It's now time to honor our guest speaker, Shri Kishore Ashok, CTO, Aero Space Tech Private Limited.
Hello, Chi.
Yeah, next we welcome Venpriyan, third year computer science, DSAI. In the title, quantum, rocketry construction, design and working.
And followed by Mr. Gokul Raj.
Followed by Gokul Raj, third year CSE, DSAI.
And quantum computing and...
Good evening all. I am Venpriyan from Department of CSE.
One second, stay. So I invite my co-chair, Kalpata ma'am, to give the introduction about the student.
I welcome Mr. Gokul Raj, third year CSE, who is going to just share his knowledge on quantum communication and quantum satellite. Okay. So I welcome you, both of you. Okay. Please share your information and your experiences.
Hi guys, myself Venpriyan from Department of CSE. I am working in this MGR Space Technology Center from my first year. So we have done many projects like CubeSat, which is our main mission, primarily focusing on 75 student satellite mission. And for in-space rocketry competition, I am leading my team in the name of Dr.M.G.R. SAT. So we have done our preliminary design review and we have selected for the second phase, which is CDR. And through my team, we have done a model of software testing and we have submitted CDR documents. It's in an evaluation phase. After that, a whole rocket will be ready and sent for this competition. So let me look into the design of our rocket. Okay. Our rocket is named as ROXA, which is ROX Alpha, which is expanded as Revolutionary Orbital Accelerator. Alpha is a version of our rocket. So, material selected for our rocket is fiberglass composite and aluminum for body. For nose cone, we are using PETG, 3D printed nose cones. So, the system uses a dual deployment and recovery system with the drag parachute, deploys at 1000 meters at 4.5 meter per second, and the main parachute deploy at 850 meters at 3.5 meter per second during its descent. Content. Target apogee of our rocket is 1000 meters. Height and wet mass of our rocket is 178 centimeter, and wet mass of our rocket is 14.5 kg. Height and wet mass of our payload. What our payload is planning is an Cancer. The Cancer's size is 35 centimeter and weighs up to 950 grams. Deployment and recovery system is mainly focused on dual bay deployment and recovery system. During software testing, the best case we have acquired is 1 km per hour wind speed. The avionics bay will be positioned at the middle section of the rocket. These are the design calculations used to build our rocket, which primarily focus on thrust formula, fuel equation, structural formula, static stability margin, lift force, drag force, factor of safeties. These are the primary systems and subsystem in detail. Avionics bay, it used to collect data from the sensors. Deployment system, dual bay and dual deployment system for safe recovery and landing of the rocket. Engine, as per our competition regulations, the engine of our rocket will be provided by the organizers. Fins, we used a new type of fin formula for this rocket. Already this roller-on concept is utilized in Sidewinder cruise missiles. So we are implementing the cruise missile technology into a rocket. That's a differentiation and uniqueness in our rocket. That is roller-ons. It works on a gyroscopic gimbal position. During its flight, using roller-ons, the fins will be adjusted and the orientation of the rocket will be controlled automatically without any mechanical interventions. Ground station, it used to transfer information to ground station. The image you are seeing of our avionics bay is comprised of sensors, Raspberry Pi, pressure sensor, atmospheric sensors, LoRa. We are using XB modules for communication between the rocket and the ground station and CANSAT to the ground station. This is the ground station setup we have done in our center, and we have made our own flight software which is used to locate the rocket's overall data from launch to recovery. These are the software testing we have done through AutoCAD, ANSYS, CATIA. This is the roller-on, what we are talking about. It's the uniqueness of our rocket. This is a quality control test and planning. In software test, we use ANSYS and Open Rocket for software testing and designing of our rocket. Next, sensor integration test. We have used both hardware and software for our rocket preparation. Flight software testing has been done through software. Parachute drop test. We have made our own parachute for both CANSAT and rocket, and we have tested from our college. This is the image of our testing. Next, environmental testing has been done physically. We have made our rocket components and we have tested in both hot and cold climates. Next, ground station testing has been done physically. This is the ground station. Through the sensors, we are receiving the data from the avionics bay, which will be presented to the rocket. Again, for this rocket, we are building both payload plus launch pad. The launch pad, right side is the design of the launch pad, what we are making for our rocket. It's a 3-legged launch pad, which the height of the launch pad is about 1,200 meters. These are the steps what we are going to follow during our launch. It's a pre-launch setup. It's first. Next, weather condition check, clearance area setup. Next, ignition system inspection, payload and telemetry check, final safety briefing, counter initiation, launch initiation, in-flight monitoring, recovery deployment, and post-launch analysis. Thank you.
Good afternoon, everyone. Today, I'm going to present about the topic quantum communication and the quantum satellites. So basically, quantum communication is a type of mechanism where we're using the quantum mechanism to transmit a data using a concept called quantum entanglement and quantum superposition. So why we need it? So the future of the communication should be more and more secure. Currently, the blockchain is secure, but even the blockchain can be cracked using a quantum computers. So for that, we will be using the quantum communication, which will be encrypting the data using protons. So quantum satellites. So quantum satellites are the extended version of a quantum communication, where we'll be using the quantum communication behind the Earth level. So by using that, we can able to transmit the data over a long kilometers. So for that, we'll be using the qubits and as a main encryption key. So for encrypting the data. Quantum communication basics. So quantum communication basics, we will be using the quantum entanglement as a primary thing. So secondary, we will be using the quantum superposition as a qubit. So non-cloning theory. So basically, we will be using the proton, which have the inbuilt capacity or the inbuilt property. While we are seeing the proton, we can proton will be changing the nature of that. So like light will be some part of a wave and some part will be particles. So like that, proton will be changing its nature. So by using that, we can able to understand. So somebody is watched our data. So proton will be changing that. So we can able to secure the data. How quantum computers work? So basically, the data will be encoded using a proton. So where will be the ultimate source of a key. So after that, the proton will be carrying the qubits to the ground level. So by using a ground stations, so they will be decrypting the data using the same proton where we will be encrypting that. So challenges in quantum communication. So even the quantum communication has a challenges. We can able to transmit the data only using a few kilometers, like in hundreds and the thousands. So for that, will be future enhancement will be coming there. The quantum satellites are the game changers. Why? Because the quantum communication as an extended version. So for that, we will be using the quantum satellites behind the Earth level. So by using that, we can able to transmit the data in a secure manner. So applications of a quantum communication are only going to be the secure communication, and the quantum internet will be coming in the future, and the scientific researches are going on there. So the future of a quantum communications. So conclusion, the quantum communications are going to be the future, and we can able to encrypt the data in a more secure way. Thank you.
Some knowledge about his experiences in ACS sat, okay. And Gokul has given the information about upcoming quantum satellites, which may be, I think, dramatic changes in the communication I can see. Okay, hope so that even our students may contribute something to the quantum satellites. Okay, all the best and thank you.
Yeah, thank you so much, students. Thanks for the initiative and effort in presenting your presentation in the wider platform. So all the very best for the both of the students from CSE department.
Dear students, you would have witnessed today the young student speakers. They are sharing the same podium where the established eminent speakers were standing. So it's up to you. Tunindavan kaidattal perugiran, tayangubavan kaitattugiran. It's up to you to stand where you want to be. With this, we would like to appreciate our student speakers. Venpirayan, third year CSE, DS and AI. And Gokul Raj, third year CSE, DS and AA. நல்லா தட்டுங்க. It's now time to appreciate and thank a chair and co-chair of the session. Dr. J. Sridevi ma'am and Dr. T. Kalpalata Reddy ma'am. Thank you, ma'am. We now invite Professor Dr. Kavita, Dean, Sir C.V. Raman Research Council, to present the concluding remarks of the seminar.
A very good evening to all present here. It's a really immense pleasure for me to conclude the National Seminar Space 4.0, Emerging Space Technology, ACS Space Technology Center. It is the National Seminar on Space 4.0 brought together 11 eminent speakers, especially 4 directors, Sri M. Shankaran, Director U.R. Rao Satellite Center, ISRO, and Dr. Vinod Kumar, Director PD in Space, Astronautical Society of India, Department of Space, Dr. A. Rajarajan, Distinguished Scientist and Director Space, Dhawan Space Center, Sri Harikota, Dr. G. Raja Singh, Tangadurai, Program Director, Ministry of Defense, to share their expertise and experiences in the field of space technology and exploration. So initially, Sri M. Shankaran, Director U.R. Rao, he has clearly articulated that India's space satellite program led by ISRO has made significant strides since launching its first satellite, Aryabhata, in 1975, and has launched over 430 satellites using more than 90 rockets, including indigenous launchers like PSLV and GSLV. Milestones like Mangalyaan, Chandrayaan, and Aditya showcase India's cost-effective innovation and scientific excellence. The INSAT, IRS, and NAVIC series continue to support the sectors like communication, navigation, and weather forecasting. He also mentioned that India has launched the satellites for over 36 countries, strengthening global ties through over 430 foreign satellite launches. Private sector and student participation have broadened access to space, with growing applications in smart agriculture, 5G, and disaster management. India's space program is set for greater global impact. He has rightly pointed out that the future lies in innovation, collaboration, and inclusive technology development. The next session, Dr. Vinod Kumar, Director, Promotion Director in Space, Department of Space, Executive Secretary, Astronautical Society of India, Government of India, has shared his insights on expanding the horizons of Indian commercial space sector through policy, regulation, and collaboration in space, launched in 2020, transforming India's space sector by promoting private participation with over 600 proposals and 8,000 plus registrations. The government now allows up to 100% foreign direct investment, 49% in launch vehicles, 74% in satellites, and 100% in subsystems under the Indian Space Policy 2023. Supportive schemes like 1 crore seed fund, 500 crore technology adoption fund, and 2-year pre-incubation program are empowering startups. 100 crore venture capital fund further fuels innovation. He rightly pointed out that India's historic lunar South Pole landing showcases its global potential, and in-space is paving the way for global collaboration and thriving the space economy. The next session, Dr. G. Raja Singh, Tangadurai, Program Director, PJ BrahMos, DRDL, DRDO, Ministry of Defense, Government of India. He delivers a talk on innovation in the success story of Indo-Russian joint venture program, BrahMos. He emphasized that the Indo-Russian joint venture BrahMos, inspired by Dr. APJ Abdul Kalam, has become a symbol of strategic defense collaboration. It was established in 1998 by DRDO, and Russia's NPOM, BrahMos Aerospace, developed the world's fastest supersonic cruise missile inducted across the India's Army, Navy and Air Force. And also BrahMos exemplifies the financial product and organizational innovation, ensuring agility and effectiveness. He has clearly explained that with ongoing enhancements, including a long-range and miniature variants, it remains key to the India's defense capabilities and global partnerships. The next session was Dr. A. Rajarajan, a distinguished scientist, a member of the InSpace Board and Space Council Director. He has thrown the lights on this topic, small is a new big. States that the small satellites are revolutionizing space research by proving that impactful missions no longer require massive spacecraft. So these compact, the cost-effective systems enable faster development and deployment, making space more accessible to startup, universities and emerging nations. Small sats are widely used for Earth observation, communication, weather monitoring, and scientific experiments. So truly, in modern space, he told that a small is powering some of the biggest. In the next session, Dr. Prakash Rao, Chairman, Project Monitoring Committee. He has thrown the lights on the topic, space environment, the first step towards a space innovation, and also how to handle the transition from classroom to clean room. His session offers the practical guidance for fresh graduates entering the space industry, particularly in a clean room environment where the spacecraft subsystems are integrated. Also, he focused on R&D settings like ISRO, share his universal lessons applicable to any first job, delivered with relatable anecdotes and light humor to keep the audience engaged. The next session, Mrs. Kalpana Aravind, outstanding scientist, ISRO, Associate Director at LEO ISRO. She has discussed on the topic advancements in electrical-optical sensors in space. Electro-optical sensors are the crucial components in space satellite orientation, determination with reference objects such as the sun, earth, stars, and magnetic fields. ISRO's initial mission started with the simple sun sensors and magnetometers, progressing to sophisticated star trackers and earth sensors for LEO and GEO missions. So these sensors are critical to attitude control, navigation, and autonomous, such as docking missions like Chandrayaan and Aditya L1 have demonstrated the cutting-edge vision and laser-based systems. The next session was Dr. Madan Bala, CTO of Asista Aerospace. He discussed on integrated opportunities in the space economy projects, promoting a practical outcome-driven mindset, and also flexibility in academic path allowed for broad exploration. He also emphasized that together these fields offer a dynamic, evolving research landscape. The next session was Dr. D.K. Gopalakrishnan. He discussed on the small satellites, big applications, the new space era, and opportunities for global collaborations for higher educational institutions. The ninth session was Dr. SPM Moin, co-founder, chief operating officer, Agnikul. He discussed on automatic launch vehicle building, which has a demand for faster, cost-effective space access to build the launch vehicles. This talk explored how the robotics, AI, and smart manufacturing are streamlining the complex process like composite layup, precision welding, and quality assurance, and how the automation is propelling us into more efficient and agile era of launch vehicle development. The 10th session was Kishore Ashok, Director CETO, Aero in Space. He is a cosmonaut trainer, aerospace entrepreneur, shared his insight on empowering women in space technology, transforming science and global collaborations, and the future of space must be inclusive and collaborative. The last session was Shri Vikram Shivaprakazan, the subject matter expert. He briefed about the satellite internet system, need and applications of satellite internet, which plays a vital role in serving the remote and underserved communities. With the advancement of laser technology, satellite internet is becoming a fastest high-speed global network. So this national seminar was a successful platform for knowledge sharing, discussion, and exploration of the latest trends and advancements in space technology. The insights shared by the eminent speakers will likely to have a lasting impact on the attendees and contribute to the growth of space research and exploration in the country. Thank you.
Thank you so much, ma'am. Yesterday and today, we would have enjoyed all the technical sessions. We had a great learnings and experiences as well. Did you agree with me? Though, as an organizing committee, we would like to have some feedback and share your experiences in the past 2 days. Any student? Yeah, please come forward. Student from last desk. Hey, podium.
Very good evening to everyone. I'm Keshav, a school student. So I am from Sri Shankara Global Academy, Pammal. This conference, I got a lot of information to know. To be frank, I felt some part boring. Sorry, sir. I felt some part boring, but it was very informative. Yeah, because I'm not a college student, right? Some terms I was not able to understand, so it felt boring for me. Maybe it might be interesting for them. Yeah. Yeah. Okay. Thank you, sir. Then I got valuable insights from many people from ISRO, and it's very hard to meet these people and all. We can't personally contact them, and MGR University has given the opportunity for us to meet them and have questions and a questionnaire session with them. Thank you.
Good evening, everyone. Actually, I am Kishore from Bharat University. Actually, this session was very, very useful for us because we are doing some projects regarding this only, using satellites and communication. And most favorite session is Kishore sir's session, which was we felt most interactive, and it's very useful for us for upcoming projects. And we got we have more knowledges, we got more knowledges regarding this today. And yesterday also, we didn't feel any lag, and we feel very useful here. Thank you.
Thank you so much. Can we have any student from the last desk? Last. As our Kalam sir said, some of the best brains of the nation can be found in the last desk of the classroom, even in the auditorium also. Even front row also can come. You are also best brains only. Please come. Applauses. Encourage your friend.
So, good evening. Myself, S. Anskanda. I'm a BTech first year in the Dr.M.G.R University. So, for the first thing, why I joined here is not because of knowing satellites or anything. So, the first thing which I came here is to see the people who are very anxious about something to do in the space, because there is few things we can't do. Like we have something in front of, we can do anything we know, or anything we have discovered, but we can't do anything which can't be discovered. So the people who came and who lectured us, the people and the respected guests. Thank you so much. I saw your like your anxiousness and the thing which you felt proud. You felt proud for the things which you have achieved. So we can see those things from your eyes. And I am very happy and I am very proud to attend this section. Thank you, sir, and I like to thank sir for connecting this thing. And my HOD ma'am, Subhasri ma'am, thank you so much for lending our first year students to have this wonderful opportunity. And thank you so much. Thank you.
Thank you so much for the encouraging words from the student to the teachers. Thank you. And anyone? Any other student? Any girl student? Any women scientists here? Yeah, please come forward.
I'm Kavita. I'm from Dr.M.G.R University, B.Tech second year CSE. I don't. I was a little bit nervous because I don't ever talk like this. Okay. The session was nice. At sometimes, what the guy once said little bit that sometimes it was difficult. Yes, sir. Sir, I want to say something to you, sir. I am also willing to join in your space club. That I was interested. Thank you, sir. First of all, we thank our sir for organizing like national seminars. Thank you, sir. Thank you, ma'am. I am from your department, ma'am. Please.
Thank you. Any other student? Certificate distributions. Certificate.
Distinguished delegates, we have come to the conclusion of the two-day seminar. I feel very happy that this 2 days seminar was very great to announce a great success.
Wow.
In my career, 48 years in teaching line, I have seen many conferences, many seminars, workshops. The conclusion session, there were never like this, the hall is full in any of the conference or seminar which I have seen. This is the one, is a great success. I feel very proud, I feel very happy. The hard work which we did for the past 1 month, today it is dream, is fulfilled by God and your presence, your cooperation. Whatever the difficulties we had, I forgot everything. Today we are very, very blessed by God that the program was very successful with the cooperation of my colleagues and students, team, and with your support. Dear students, you have been included in our WhatsApp group, the third seminar. The first 2 seminar participants also, the same group, you have been included, and you will get continuous update about the developments of space technology in this group also. My guru. Who is my guru? Who is my guru? Abdul Kalam. I closely associated with him from 1984 to till his last day, I was his friend. 31 years. He used to say, dream, 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 dream big. Aiming small is a crime, he said. According to his suggestion, yesterday I got a dream. You know what's the dream? I feel that I am going inside the ISRO. In that ISRO, I met 275 students who attend the seminar. There, as a scientist, I have met them in the dream. I don't know whether the dream will come true, reality. But it is my dream. You should become a scientist of ISRO and NASA and the allied industries. There's a tremendous scope. So I don't want to take much of your time. I continue to work for this field. I will create more scientists in this field. It is my ambition. So far I have trained 100 students past 3 years in this center. Now, those who are in the first year now or the second year, there will be a test to select the fourth batch. The Google form will come. You can enter into that. You can very well join in our team. I will give priority only those who attended the seminar. Okay? And you can see outside the photographs, the past 3 teams, they visited many conferences, workshops, internships, etc. I would like to introduce to you some of our students' team. Rocket team, cancer team, please come. Rocket team, cancer team. Rocket or cancer? Cancer. Where is association? ಯಶಸ್ವಿನಿ ಇಲ್ಲ. ಹರಿಚೆಲ್ವಮಿಂಗ ರೋಷನ್ ಹರಿಚೆಲ್ವ ಅವ ಕೋಟ್ ಕಳ್ತಾರ ಒಬ್ಬರು. Why I am introducing them? They are from, most of them are computer science field. They are not much known about the mechanical, electrical systems, but they learned, and not only learned, they participated in the national competition, and both teams, they got selected in the national competition. So give them a big hand to these students. This is what our dream. Even though I am a mechanical engineer in the field, I worked for my PhD with Abdul Kalam on missile technology, tissue missile, starting with. Then we worked Agni, Akash, Prithvi, Nag and BrahMos missiles. So, if you have interest, that can be converted into talent, and then that can be performed as a success in your field. So, these students are very hardworking in nature. They learnt their own. I did not help much on them except coordination. They worked hard, very hard. They learned from faculties of engineering and mechanical, electrical, electronics. And today, I am sure that they will be the great scientists in this field. My hearty congratulations to all of you. One student who went for training at a satellite application center. Arun. 75 days he took training in space application center at Ahmedabad. Another 4 students, tomorrow they are leaving for Bangalore. Tomorrow, these 4 students are leaving for Bangalore to have internship for 4 months. That was selected by Mr. Sankaran, the director of Bangalore MGR-ACS Center. They will be going tomorrow to Bangalore, MGR-ACS ISRO Center at Bangalore for 4 months. Congratulations. Why I am introducing them? They are away from their own specialization like computer science. But this Space Technology Center is a common to all branches. It doesn't that I am computer science, I don't know about satellite. Or civil engineering, I don't know about it. All that, if you take interest, you can be one of the scientists in ISRO. And now it's time for me to thank my HODs. Just 5 days before, I had a very limited enrollment, but just 5 days before, our HODs came forward to help me. Now the program is overflowing, more than the capacity. We have got enrollment and we are accommodated. And wholeheartedly, I thank the Dean of Faculty of Engineering Technology, the HODs of Mechanical, Electrical, Electronics, Biotechnology, BIB, and Computer Science, IT, all HODs are working cooperation. So, we will honor them. Yeah. Yes. So it's my privilege and honor to give great congratulations to my HODs. I hope this interdisciplinary cooperation will continue and establish our one more dream what we have. We want to start B.Tech Space Technology and M.Tech Space Technology in our university soon.
We invite our Dean Ethiraj sir onto the stage. We are about to honor our HODs of Engineering and Technology. We would like to invite HOD CSE, Dr. S. Geeta ma'am onto the stage. Thank you, ma'am. We would like to invite EC HOD, Dr. Jayalakshmi ma'am onto the stage. Thank you, ma'am. We would like to invite IT HOD, Dr. N. Kanya ma'am onto the stage. We would like to invite HOD Biotechnology, Dr. Gomati ma'am onto the stage. Thank you, ma'am. Would like to invite Dr. K.S. Divya, HOD Biomedical Engineering ma'am onto the stage. Thank you so much, ma'am. Dear students, we would like to appreciate and acknowledge your presence in the form of certificate. இளமையில் கல்வி சிலைமேல் எழுத்து. That means what you learn in your young time that remains forever. So in that way, we would like to appreciate and congratulate Shankara Global School from Pamal, who have arranged a team of 15 students, and they have been attending the seminar for past 2 days. And we would like to appreciate the vice principal of the school. Ma'am, we would like to have you onto the stage. The memento. Thank you, ma'am. Thank you, children. And next we have young engineers from Bharat University. We invite them to come up on stage. Thank you. Next we have young engineers of MGR. Can you guess who are young engineers of young engineers of MGR University? Who are all? Huh? Final year? Third year? Second year? Yes. So now we cannot have all those first year students as we are a massive strength. So we need 10 to 15 students on stage. All the certificates will be handed over to a joint registered madam. You can collect from her, okay, from the office. Now we would like to have 10 to 15 students on stage. No. Feedback யாரு சொன்னீங்களோ இப்போ மேடையில வந்து நிக்கிற எல்லாரும் ஃபீட்பேக் சொல்லணும்.
Students, give a big round of applause.
And next we are entering into the core department. We would like to call the students from CSE. CSE, second year, third year, final year, any student is here? Put up your, few students can come up on stage. Come fast. Likewise, next department is ECE department. To get ready. Second year, third year, and final year. ECE students, put up your hands. Where are you? ECE students, come fast. And next, IT students, get ready. Which department? Hey. IT students, put up your hands. IT. Get ready, come forward. IT students. Students from IT department. Civil department. Civil, mechanical and biomedical engineering. To get ready. invite students from Civil Department, BME and Mechanical. Any student from Civil Department? Civil Department, Civil, Mechanical, Biomedical Engineering. Any Chemical Engineering student is here? BME students, can we have BME students on stage? Second year, third year and final year, put up your hands. BME students, biomedical. Students to settle down fast. We request satellite students to come forward. As a token of love and respect, we would like to honor Dr. J. Sridevi ma'am, Dean H&S, for her enormous support in the National Seminar 4.0. Thank you so much, ma'am. The Seminar 4.0 left us with more learnings and experiences as well. Can we take 10 minutes of yours? Will you be attentive? Because this is the time we are going to appreciate and acknowledge the greatest minds behind the show. So we need all your applause. Yes? இதுக்கெல்லாம் வெகுமதி என்னவா இருக்க முடியும்? கைதட்டு மட்டும்தான். We need your 10 minutes. So we are mindful and thankful to all the grateful hearts behind the success. Keep your men on toes. அப்படின்னு சொல்லுவாங்க. ரெக்டர் சார் எப்பயுமே பெருமையாக பேசும்போது எங்கிட்ட ரொம்ப நல்ல ஸ்டூடெண்ட்ஸ் டீம் இருக்காங்க, எங்கிட்ட ஒரு பிரமாதமான ஸ்டூடெண்ட்ஸ் டீம் இருக்காங்க அப்படின்னு பெருமையாக சொல்லுவாங்க. டாக்டர் எம்ஜிஆர் ஸ்பேஸ் டெக்னாலஜி சென்டர்ன்றது ஒரு தோட்டம் அப்படின்னு எடுத்துக்கிட்டா அதில் இருக்கிற ஸ்டூடெண்ட்ஸை ரெண்டு வகையாக பிரிக்கலாம். ஒன்று முகம் காட்டாத வேர்கள், எப்பயுமே சிரிச்சிட்டு இருக்கிற பூக்கள், அந்த மாதிரி ரெண்டு வகையாக பிரிக்கலாம். சில குரூப் எப்பயுமே வேலை பார்த்துட்டே இருப்பாங்க, சில குரூப் நல்லா இன்ட்ராக்டும் பண்ணுவாங்க. அண்ட் இன் தேட் வே திறமை என்பது கண்டுபிடிப்பது கிடையாது, அது முற்றிலும் வளர்த்து கொள்வது. நீங்கள் நினைத்தால் எதில் வேண்டுமானாலும் திறமையை வளர்த்து கொள்ளலாம். அப்படி திறமையை வளர்த்து கொண்ட கூட்டம்தான் இது. இது தானா சேர்ந்த கூட்டம் இல்லை, மூழ்கி எடுத்த முத்துக்கள். நீங்கள் பார்த்தீங்கன்னா போஸ்டர் டிசைன்லேருந்து பேனர் டிசைன், சர்டிஃபிகேட் டிசைன், 3D பிரிண்டர், நீங்கள் மெமெண்டோ பார்த்துருப்பீங்க இல்லையா, 3D பிரிண்டர் டிசைன், அதுக்கப்புறம் ஃப்ரண்ட்டில் டெக்கரேஷன் பார்த்தீங்க இல்லையா, ஸ்பேஸ் 4.0, அந்த டெக்கரேஷன் டிசைன், ஈச் லெட்டரோடைய டிசைன், ஈச் லெட்டரோடைய கட்டிங், பின்னாடி ஒரு ராக்கெட் மாடல் பண்ணியிருந்தாங்க இல்லையா, எல்லாமே ஸ்டூடெண்ட்ஸோடைய கைவண்ணம் தான். தோட்டத்தில் எல்லா மூங்கில்களுமே புல்லாங்குழல் ஆக முடியாது. ஆனால் எங்களுடைய சேட்டலைட் சென்டரில் எல்லா மூங்கில்களுமே புல்லாங்குழல்கள் தான். And we would like to have students. Harishwar, final year CSC, DS and AI. Banu Prasad, final year CSC and AI. நல்லா கை தட்டுங்க. Roshan, final year ECE. Yashashmi, final year CSE AI. Arun Kumar, final year Robotics and Automation. Rajvelu, final year Robotics and Automation. Venpirayan, third year CSE, DS and AI. Pranava Kumar, third year IT. Gokul Raj, third year CSE, DS and AI. Arun, final year CSE. Harichelvan, final year CSE, DS and AI. Pravina, third year CSE, DS and AI. Priyanka, third year CSE, DS and AI. Sam Daniel, third year CSE, DS and AI. Dinesh Kumar, third year CSE. Afsal, third year CSE. Manoj Kumar, second year mechanical. Dhyaneshwar Bala, second year mechanical. Karthik, second year mechanical. Murshid, second year CSE, DS and AI. Madhu Kavi, second year biotech. Monica, second year CSE, DS and AI. Ramachandran, second year ECE. Aditya, second year CSE, DS and AI. Naveed. Naveed is here. Naveed, third year CSE. Vedavalli. Gayatri, second year biotech. Devi Balan, second year CSE. Kishore, second year biotechnology. Akhil, end year? Akhil Thomas. Akhil Thomas, second year CFIS. We would like to thank and appreciate the staff team behind the success. We would like to call Dr. Anthony, professor from CSE, Dr. Gerald, professor from CSE, Dr. Raja, professor from CSE, Dr. Kavita, professor from physics, then myself, sir.
Dr. B. Lata, Professor of Physics. Dr. V. Sai Shanmugaraja, Professor of CSE. Mrs. J. Saranya, Assistant Professor, FOCA.
To have professor from Department of Physics.
Dear students, 1 minute, listen to me. Listen to me, Cap. Listen to me for a minute. See, as already I told you in many occasions, our university, we wanted to have a distinct identity through the satellite and then space application. You are aware, there are a lot of opportunities awaiting for young mind like you. But when the same challenge was given to us, especially to me 15 years before, I could not able to, have that confidence to establish such a center. So then, luckily, 4 years before, we got our Professor Dr. Viswanathan, who came as a rector to our university with the mighty experience of controlling around 570 engineering colleges across Tamil Nadu as the Anna University Vice Chancellor. Then the moment he landed into our university, he interacted with all of us. Then he said, why don't we have a unique platform for our university, for our students to be created? And then we said, yes, sir, you just initiate, we'll be behind you, your activities. So this is what actually happened 4 years before. Then within 1 year, we have started this Satellite and Space Application Center. So now you know the journey of this Satellite and Space Application Center. Dear students, it is a continuous
Dear students, நீங்க சார் பத்தி விஷயம் தெரிஞ்சுக்கணும். நீங்க எல்லாரும் உட்கார்ந்து லெக்சர் கவனிச்சீங்க, கரெக்டா? நல்லா உட்கார்ந்துட்டு சொகுக்கிட்டு ஃபோன் பார்த்துட்டு லெக்சர் எல்லா டெக்னிக்கல் செஷன்ஸும் எத்தனை தடவை உங்க கூட ரவுண்ட்ஸ் வந்திருப்பாங்க? எத்தனை தடவை ரவுண்ட்ஸ் வந்திருப்பாங்க? His age is just numbered. See, at this age, they are so active. அதுக்கு காரணம் என்ன தெரியுமா? I will read. Just follow. I want to quote lines from literature. நல்ல ஆவின் அப்படின்னா பசுமாடு, ஓகே? நல்லாவின் பால் முழுதும் கன்றிற்கில்லை, நறும்பூவின் மனமெல்லாம் சோலைக்கு இல்லை, நெல்லாகும் கதிரெல்லாம் நிலத்திற்கு இல்லை, நிறைகின்ற நீர் முழுதும் குளத்திற்கு இல்லை, உண்ணுகின்ற கனி முழுதும் மரத்திற்கில்லை, பண்ணாகும் இசை முழுதும் யாழுக்கு இல்லை, எல்லாமே பிறர்க்கு உழைக்க காணுகின்றேன், என் வாழ்வும் பிறர்க்கு உழைக்க வேண்டும் வேண்டும் வேண்டும். இது ஒன்று தான் சாரோடைய லட்சியம்.
Thank you all very much. I dedicate this honor to all my students. After my retirement from Vice Chancellor post, after 1 month, I met Abdul Kalam at his house in Delhi. You know, Kalam was my guide in my PhD. We are friends from 1984. In 2007, when he retired as a president, I invited him to Anna University as a professor. So he joined with me the last day of his president post, 4 hours before his ending time. That is midnight, 25th July 2007, till midnight he was the president. But 8 o'clock he landed at Anna University. So from 8 to 12, he is the president of India. So 500 security personnel were in the campus. I was the boss to the president of India for 4 hours. Then he was with us as a visiting faculty. When I invited him, he did not answer me properly. No, I have to go to Indian Institute of Science and Technology, Nalanda University. I cannot decide to come to Anna University. I said only one line, sir, you joined as a president only from Anna University. So it is your duty to come back to Anna University as a faculty and then you go to any other place. Then he agreed, he joined with Anna University. So when I met him after my retirement, 1 month after, he asked me, what are you doing? Summadan sir, he got angry. First time I saw how he got angry. How can you be idle? What is your qualification? What is your experience? You want to go everything waste? No. What's your age? It is only 55. So you should continue to help the young minds. Your experience and knowledge should be useful to the young minds. They are going to be the future leaders of India. Do not waste your time, he said. No, sir, just I retired. No, this 1 month will come back again. You know that you are going to retire, then you should plan for the next day onwards where you have to be. Like that, and he said, till your last breath, you should be useful to the students. Dear students, today I declare in front of you, the rest of my life, till my last breath, I want to help the young students. That is my prayer to by God. Thank you all for your wishes. I wish every one of you to flourish and become a leader and safeguarding our India. You know how Kalam dedicated himself for the nation. One day I asked him, sir, why you did not get married? He said, my family, when they started seeking alliance in my age, I had a deep turbulence in my mind. What should I do? I am working in the rocket project. I have to work from morning 8 to midnight 12. If I continue to work like this, I may be doing injustice to my family once I get married. So I should see whether I have to take care of my family or the nation. I love my nation more than me. I have to achieve this goal in my life. So better I should not have a family and I should love only my nation and dedicate myself. So I did not get married. So like this, we need to take the glue. That's why when I got a job in US, when I presented my technology, I got a job in 1988 to work in an American company as a missile manufacturing company. They offered me a job saying $4,000 per month in the year 1988. I said, thank you. I born in India, I will work only for India, not for America. So that way, I got the patriotism learned from Kalam. Dear students, you think of your nation always. You will be always a leader and generations-wise. In India is now progressing very well when compared to other countries. It is in your hand. In 2047, India will be the superpower because of your role in that one. Wish you all the best. Thank you.
Thank you so much, sir. உயர்ந்த குணத்தின் முதல் தகுதி அது என்ன தெரியுமா? பிறருடைய திறமையை மதிப்பது. And we are very fortunate to have additional registrar Dr. Cyril sir. Have you as our additional registrar. Thank you so much sir, and you are our pillar of support in all our endeavors. As I said in the last year, the same words. பொன்னியின் செல்வன் படத்துல கலபதி கேள்விப்பட்டிருப்பீங்கல்ல? தலபதி இல்ல, கலபதி. He is a very important person who navigate in such a way, same way, sir navigate between the management, students and the faculty. Thank you so much, sir. Once again, we thank each and every one of you for being here with us for the past 2 days. Thank you. Space 4.0 National Seminar. இனிதே நிறைவடைகிறது. நாட்டுப்பண்.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे